Hey everyone, it's Miss Brooks with your daily dose of math. Today we're going to be focusing on section 1, operations on real numbers. Even though it's called operations, we're honestly going to be working on classifying real numbers. So let's take a look at all the different numbers that there are. The real number system consists of 5 different types of numbers. We want to take a look at each of the types so we can classify our numbers appropriately. The first type of real number is what we call the natural numbers. A natural number is the set of numbers greater than 0. So for example, I have created a set of natural numbers at the bottom. We have 1, 2, 3, 4, 5. And we could keep going on forever and ever. Notice, however, that I do not include any decimals or fractions. Natural numbers are numbers that I could represent by going along and counting with my fingers. So 100 would work, 105 would work, 1,000 would work, but numbers such as 1/2 would not work for natural numbers because that is not something I can represent with my fingers. It's got to be single digits. The second type of number that we have is what we call the whole numbers. Whole numbers are the set of all natural numbers and 0. So we have the same numbers as the previous set, but this time we also include 0. The third type of number is what we call an integer. An integer is a set of all negative and positive numbers. So if you take a look, the subset that I have written, we have -3, -2, -1, 0, 1, 2, 3. Notice we do have the ... dots, meaning it will go backwards and forwards. Those are just a few of the examples. So something such as -100, +100 would also be considered integers. Again, we do not have any decimal or fractions at this point. All we have are single values. Okay? There are no decimals or whole numbers to this point. Fourthly, we have the rational number. A rational number is a set of all numbers that can be written as a ratio. Just remember, a ratio would be a fraction. That means it also can be written as a decimal. These decimals can be repeating decimals or terminating decimals, meaning that they end after so many places. So if we take a look at the examples, rational numbers are when we finally get to take a look at decimals and fractions, as well as still having those whole numbers and integers. So some of the examples, we have 5, we have 0, which we also have seen in previous types of numbers. But now we also have fractions, such as 1/2. We have repeating decimals, such as 0.2. That bar at the top means that it's repeating. We have terminating decimals, such as 0.78 or 0.125. And we can still have negative numbers, such as -10. So until we get to rational numbers, we did not have any fractions or decimals. At this point, we now do. The last type of number that we want to take a look at are the irrational numbers. Irrational numbers are off in their own little world. So they're kind of over here in La La Land. They are not related to anything we've looked at so far. Irrational numbers are the set of all real numbers that aren't rational. So that would mean any decimals that go on forever and ever, or any imperfect square roots. So some examples of that, I have a decimal that's going to keep going. I know it keeps going here because I put a ... at the end. The most famous irrational number is pi. Pi is a never-ending decimal. And then we also have imperfect square roots, such as the square root of 5. 5 is not a perfect square, so the square root of that would be a decimal that goes on forever and ever. Those are all examples of irrational numbers. Now, when we classify our numbers, we can classify numbers more than one way, and we always want to make sure we classify them with as many different ways as possible. So if you take a look, this sheet kind of makes a nesting system. We see the natural numbers are a subset of the whole numbers. So if I ever classify something as a natural number, it's also a whole number. The whole numbers are also a subset of the integers. So if it's a natural number, it's also a whole number, which is also an integer. Integers are also a subset of the rational numbers. So if it's natural, then it's also whole, then it's also an integer, then it's also rational. It does not work the opposite way. We cannot go from top to bottom, but you always go bottom up. So if I started with an integer, I would also have to say it's a rational number. Irrational numbers cannot be any of these four to the left. Irrational numbers are their own thing. Now, no matter how I classify the number with these 5 different titles, every single number will also be real for what we are talking about. So I should always classify my number as real, as well as using the other 5 terminology. So let's go take a look at a few examples. We're going to start by taking a look at a few examples. First, we're going to practice classifying the number 10.5. 10.5 is a decimal, as you can see, and decimals were either rational numbers or irrational numbers, depending on what kind of decimal it was. Since 10.5 is a decimal that ends, it stops at 0.5, this would be a rational number. Now remember, anytime something is a rational number, we also would say it's a real number. So 10.5 would be classified as a rational, real number. The next number we want to take a look at is 6, and being able to classify 6. Since 6 is not a decimal, I know it is not going to be an irrational number. So what I want to do is figure out from the left column, what is 6? 6 is a positive number that can be counted on my fingers. The positive numbers began with the natural numbers. So I would start by classifying 6 as a natural number. Now, due to the nesting system, we also want to classify 6, a natural number, as everything preceding it. So we also have that 6 would be a whole number, that 6 would be an integer, and that 6 would be a rational number. Again, all 4 of these types of numbers are part of the real number system, so we still need to classify these as real numbers as well. We have natural, whole, integer, rational, and real. So do not forget about that nesting system. Work from the inside out, from the bottom up. The next number we're going to take a look at is the square root of 2. So the square root of 2, whenever square roots are involved, you want to ask yourself, can I simplify that square root? Square root of 2, that's not a perfect square, so we do not have the square root of 2. So anytime that you have an imperfect square, you cannot just take the square root and tell me this is what number it was. That is going to be an irrational number. Irrational numbers are numbers that never end, they go on forever, or they are imperfect square roots, just like the square root of 2. So again, this one right here was an irrational real number. Do not forget to always classify these numbers as real numbers as well. Now that we've done 3 example problems, I would like for you to try to classify the following numbers: 4/7, 0, and -29. Please pause the video and try to classify these numbers on your own. When you believe you have classified them correctly, resume the video and check your answers. Make corrections as needed. 4/7 would be classified as a rational real number. It is rational because 4/7 is a fraction. It is real because everything we've classified again is part of the real number system. 0 would be classified as a whole number. It is not a natural number. It begins with the whole numbers. Therefore, it is also an integer, a rational number, and a real number. Lastly, -29 would begin as an integer. The negative numbers began with integers. It would also then be a rational number, and we cannot forget that this would also then be a real number. So please do not forget that third classification. It's an integer, a rational number, and a real number. Well, this concludes our lesson on classifying numbers. If you have any questions, please ask me. Do not be afraid to ask. And we'll see you next time for your daily dose of math.